Hey, this is Alex Nielsen,
This is Dominic Radley.
and this is our Project 7, where we made a Pokemon battle simulator that essentially reads the names, the stats, and the types of Pokemon from a CSV randomly to generate a team where you then fight in a Pokemon battle against a computer that has a similarly generated team.
Yep. And so for our project, we decided to use Java FX libraries in order to create our user experience. And we also utilized Scene Builder, which is a creative tool that allows for easy creation of .fxml files for scenes in the UI. It's pretty much just a lot of drag and dropping boxes, text fields, buttons, adding IDs to them, and giving them on action events to follow. It was a big challenge since neither of us have dealt with JavaFX before, and it was something that we wanted to learn more about and utilize for our final project. So let me start it up right now. The first screen you'll see is our home screen for our game. Just says Pokemon, as well as a start game button right there.
And then once the simulation is started, that is when it creates the simulator object that we're using for our data structures in order to store all the information about these Pokemon.
So here's our Pokemon select screen. So we can choose from any 5 of the randomly chosen Pokemon that have been placed on our team. I'm just gonna go with this guy. And so this is the battle screen. And so right now, as you can see, starting from the top, you see the health bar of your opponent, and your opponent's name will show up in the top right there, as well as your own health bar, and your name. The purple oval object behind there is just to symbolize whose turn it is in the game, and whether or not it's your turn to choose an attack. Moving down to the 5 red buttons at the bottom there. The first one on the very left is a switch button. This button can be pressed at any time during the player's turn to go back and choose a different starting Pokemon. Maybe now I want to use this guy. And as you can see, the health fields also updated with the health of this new Pokemon. And moving on to the rest of the buttons, we have 4 attack moves. One is common throughout every Pokemon. It's Protect. Basically means that that Pokemon is now invulnerable to damage for the next turn. And then the other 3 buttons are their attack moves. So starting from the left and going to the left would be the strongest, and then the right would probably be the weakest. Looks like I did a lot of damage to my opponent, and as you can see, his health bar went down just a little bit. So it looks like our opponent here also used Protect. So they didn't damage us at all, but this next turn we won't be able to hurt them. So I'm just going to click the next button right now. And again, the purple oval moves down to symbolize whose turn it is in the game. And then from here, I'm just going to try and play the game. Our starting Pokemon died. So that means our first Pokemon here is dead, and we can't use them. So we have to choose from the rest of the 4 over here. I'm going to go back to this guy. It looks like we also killed our opponent in that turn. So whenever the opponent Pokemon dies, it moves down to the next Pokemon in its party. And so now the health fields have regenerated, health bars are back up, and we continue our battle. Battles can be very short, very long. Looks like we killed another one of their Pokemon, so they're on their 3rd Pokemon, and looks like my guy is just about ready to die right now as well. Again, if I were to use Protect, you'd see his headbutt did nothing to me. I was invulnerable during that turn, so You can use that as a defensive maneuver whenever you feel stuck or kind of cornered.
Another thing with the moves is that the names, because the amount of information required to actually do moves the way they work in like the newest Pokemon game, for example, it would require a whole new data structure and also probably some sort of Python script to go to like the wiki of each Pokemon that was selected to like find its move set and return that and then randomly decide on moves. But we opted to not do that because it just adds a lot of needed complexity where that's not really the goal of this project. The main goal of this project was to learn JavaFX and how to connect it with like data structures and utilize those to make an experience like this. Because of that, the name of each move is just decided based on its type because there's 18 types. It would just take too long to add in more names for more types of moves, and we felt our time was better spent elsewhere.
Gonna try and finish out this battle here. I'm down to my last Pokemon, it looks like, but I'm pretty confident, and we got the win. So right here, we got the winning screen, and again, the game is prompting us to start a new game. And of course we can. And if I press that button, it returns to the home screen, and where we'll start the game again with a whole new team, whole new opponent's team, and you can pretty much play indefinitely for as long as you want. All starts with the user interface, of course, which sets up our home screen there, and brings up the simulation. That home screen will call our controller for the UI. And then the controller is where we will initialize our simulator object, our logger object, as well as a team object, which houses all of the information and data that the UI needs, just in a separate class that can get updated and retrieved information from. That's decoupled from the rest of the processes of team control here. And we get down to initialize, where we initialize all of those elements with information from either the simulator object or from the team object. Before we get to the functions that those buttons correspond to, such as start game, which just changes the scene pretty much. And some of the better ones are like Pokemon.change. This is the function that allows for changing of opponent Pokemon once they die. And again, much of the code it lays right here in the start battle function, which sets all the information for the current Pokemon party, the current Pokemon chosen, same thing for the opponent, all those health fields, everything we can need to boot up the UI with the correct information. And then all of the damage logic and battle logic can be found within check move, which utilizes many helper functions like damage and stop, and get line to fix the line length of the health bar.
Essentially, this is our decorator that we used because in Pokemon, each Pokemon has one or two types and every move has a type. And so we decided the best way to manage this is to make a decorator that you can apply to both moves and Pokemon that can have either one or two types and that is easy to work with essentially when trying to check types for name and especially when generating moves and things like that. And so basically it's pretty simple. You just input what type you want in the constructor, and that happens in the creation or the constructor of Pokemon. So essentially in here, the constructor takes a line from the CSV file and it splits it up by commas, and then it takes the information that we're using from the corresponding indexes, and then it creates a move set for the Pokemon based off of the types every Pokemon is given Protect, which is just a move with nothing in the constructor. It's an overload that we use since every Pokemon has Protect. So since we were using it so much, we decided it would make sense to just make it the default. In the move file, essentially, is where the calculation for damage is made, and the move, whether it was successful, whether you crit, the damage, whether they protected, all of this is outputted to the logger that we're using, that is essentially at the back end keeping track of everything that's going on and logging it to a results files that we can use for debugging if something crashes. And it's also just very useful for making sure that things happen in the right order and stuff like that.
Pretty much every file that we talked about contributes to this class. We got our player objects, which player one is the user, player two is the CPU, our singleton constructor for simulator, and our Git instance for it. This pretty much allows for only one simulator or simulation to be running at once, so we're not having multiple games or teams aren't getting shuffled around. Just keeps everything pretty simple. This function will allow for creating new games. So it takes that sim, makes it null. So then when the page reinitializes, it'll go back and get that instance and create a new simulator object. And then from here, we read in the CSV, we create our Pokemon list, where we assign Pokemon to those player objects. And that will basically fill their party. And this function pretty much acts as a factory pattern for the creation of Pokemon using the decorator pattern of Poketypes in order to accomplish that. And of course, our logger is using an observer pattern in order to keep track of every event that occurs throughout our program. And the creation of team objects and simulator objects, just as we went through, are all singletons and are accessed through Git instance functions, which allow for, again, only one instance of the object to be alive during the process of this program. So to divide up the work, we pretty much cut it down in half. I was going to work on the UI, so working with the Java FX libraries, installing them into our environment, learning Scene Builder and building the different .fxml files, and trying to get the controller to work as best I could. Pretty much just trying to hook up the UI with Alex's logic.
Yeah, and then I basically wrote all the generation and reading from file and the simulator objects and all the data structures and all the like type and move generation and the Pokemon generation, stuff like that.
Yeah, and the biggest obstacle I ran into during this project was just that I didn't know a lot about Java FX. I was very much learning on the fly when I was building the different scenes and the different files, and I had to seek out a lot of sources and research to figure out what exactly it is that I'm trying to do with these libraries and how best to utilize them for our project. The biggest thing was there was a lot more of a time sink, just trying to figure out how to install Java FX and get the .fxml files to show and to work with our Java classes. That was just a bit more of a time crunch than we expected.
Yeah, and then my biggest obstacle was probably trying to reconcile what I wanted to do with this program and what was realistic for this project, because I wanted to do things like implement the whole type chart, where I basically explored a few avenues of doing that, and all of them would basically make things much more complicated when linking up the data structures that I made with the UI that Dom made. And so I decided against it eventually because it is still functional even without the type chart matchups.